Hello everyone. In this video, I want to continue where I left off in a previous video where we were working in a folder called list fun. We derived this main.py file which provided an introduction to working with lists in Python. We went over a lot in that video. Let's browse through the code and see what we went over. So we went over how lists are declared, how to index into lists using subscript notation, how Python supports both positive and negative indexing. We saw some list methods like append and remove. We saw an application of built-in list functions like len. We also saw how we could iterate through lists using for loops and while loops. We saw list concatenation. We saw list repetition. We saw list slicing. So much stuff was covered in this video. I want to continue right where I left off, which is going over some more common list methods. So we know about append, we know about remove. Let's continue on. Let's start with extend. Extend is actually a lot like the list concatenation operator where you can add two lists together. So let's say I have candies. We've got Twix, Oreos, Snickers, M&Ms, and Starburst. And let's say I want to extend this list to contain the elements of another list. So I can call extend and pass in that other list. So maybe I'll do something like Skittles and Reese's. And I'll print out candies. And all of the elements in this list will be appended one by one to the end of candies. And we see them right here. So like I said, extend is a lot like the list concatenation operator plus assignment, so the plus assign. Next, let's take a look at pop. So pop is like remove, but is a position or index-based removal. So let's say I want to get rid of the first element, which is Twix. I can call candies.pop and pass in an index, and the item at that index will be removed from the list and it will be returned. So that's why I have an assignment here, so I can store that first element in a variable which I'm calling first candy here. So I'll print out first candy, and then I'll also print out candy so that we can confirm that it's gone. So there's Twix, that's coming from first candy, and then we see candies, the list. And sure enough, Oreos is now the new first element because we've popped Twix out. Next, let's take a look at how we can create a string from a list of strings. So kind of seeing the relationship between strings, which are sequences of characters, and lists, which are sequences, list of items. So for example, let's say I have a word. I'll do Twix, but I'm going to spell this word as each character as a string in a list. So maybe I'll do Twix. And now I want to create a string from all of the elements, which are strings themselves, in Word. In fact, to be really clear, I'm going to call this word list. Because with Python, since we don't put the types when we declare our variables, sometimes just looking at the variable, unless it's well named, is a little difficult to know what is this actually storing. So word list. So it's got a list of strings which together form a word. So now I'm going to create a string from word list by joining all of the strings in word list together with the empty string. So I'm going to do empty string dot join. So join is actually a string method, and the documentation here says concatenate any number of strings. The string whose method is called is inserted in between each given string. The result is returned as a new string. So if I don't want anything in between the T and the W and the I and the I and the X, then I will use the empty string and I'll call join on it. Pass in word list. And then I'll print out word stir. And there's Twix. Now, what's cool is, let's say I want to put stars in between each one of these elements, I could do that by replacing the empty string with the string that contains a star. And now you can see these are all joined or stitched together by stars. Now let's say I want to go back. So I've taken a list of strings and stitched them together with join to make a string. Now let's say I want to go back from a string to a list of string. So there's a built-in function in Python called list, which can be used to convert a string to a list. So let's do word list 2, and this will be list, open paren, close paren to call the function, and then in here I'll pass in word stir, and I'll print out word list 2. So you can see here, every single item, every single character in the string is now its own element in the list. Now let's say I had the W and the I together as a string. I run this again. When I convert to a string using join, I lose the fact that W and I was one string instead of separate strings in the original word list, and that information is lost. So when I call the built-in function list to try and convert a string into a list, it really is going to break down each character into its own item in the list. So just a heads up there that this kind of combined character string element up here isn't going to be preserved when we take it to a string and then back to a list. So it's not truly producing the exact same list as we had before, even if I take out the stars. The next topic here is actually another string method called split. And the split method is super, super, super handy. And I'm going to motivate it by talking briefly about the CSV type. So CSV stands for comma separated value. And it's commonly used to store data that is in spreadsheet form. So if you had a CSV file, you could open it up in Excel, for example, and its data would be loaded nicely into rows and columns. So in a CSV file or in a CSV format, or if your data is in the CSV type, then rows of data are on their own lines, and values within a row, which form columns, are separated from each other by commas. So for example, if I had, say, A, comma B, comma C, this would be data in CSV type or CSV format because the values, A, B, and C, are separated from each other by commas. So let's say I used a comma to join together my T, my WI, and my X. Now let's say I want to break apart my string and create a list again, but I want to preserve the fact that WI was a single element in my original word list. I said just a few moments ago that with the built-in list function, we can't preserve that. But we can if we have a special value like a comma that is separating elements, because we can split the string into their individual elements by splitting on the comma. So let's take a look. Let's say I have word list 3. I assign word list 3 word stir dot split, and you can see the documentation here. It says return a list of the words in the string using sep as the delimiter string. Sep is the delimiter according which to split the string. So if I want to split the string into individual values, then I'm going to split on comma. And so I run this, and look, I am able to preserve the original grouping of WI together as a single element in word list because the comma is used to denote the different values. So that's what's cool about split, is you can essentially take a string and break it into individual values if those values are separated by some kind of special value. And it doesn't have to be a comma. Let's say I put in a star again. Okay, well, there was nothing to split on comma when I took away the commas, But if I try to split on star, then I can get the same results. What I'd like to do now is apply what we've learned about lists by solving some one-dimensional list practice problems together. I'm going to paste in our main.py here what I'm calling the 1D list practice problem, which has 5 subproblems that all operate on a 1D list of 20 random numbers. So the first part here, lines 99 and 100, say write code that generates 20 random numbers between 1 and 10 inclusive and puts them in a 1D list. The program then does the following using the list. And then there's 5 subproblems to solve that all operate on this 1D list of 20 random numbers. So let's start by building this list of 20 random numbers. So first, I'm going to import the random module since I need to use it to generate some random numbers to fill our list. So at the top here, make sure you have import random. And then what I'm going to do is I'm going to seed our random number generator so that we get the same results every time we run our program, meaning we always have the same numbers filling our list. So I'll seed this with 0. Now I'm going to have a 1D list called numbers that'll initially be empty. And with a for loop that runs 20 times, I'm going to append a random number between 1 and 10 inclusive to this list called numbers. So I'll do for I in range 20. And I'll note that I'm not actually going to be using I inside of the body of this for loop here. So I could put an underscore here to denote an anonymous variable, meaning I don't need this variable to have a name because I'm not going to use it. Now what I'll do is I'll generate a random number using random.randRange. So I want 1 to 10 inclusive, so that would be 1 inclusive to 11 exclusive since I'm using randRange. Now I'm going to take numbers and call append, which is a list method, that will add whatever I pass in, which in this case will be random, to the end of the list. And just to take a look at our list and make sure that it's built correctly, I will print it out. So here's our 20 random numbers. Note that there are no numbers less than 1 or greater than 10. That's awesome. It means that we do have 20 random numbers between 1 and 10 inclusive. So this is a pre-step for the rest of the 1D list practice problem, which is subproblem 1, 2, 3, 4, and 5, which all operate on this list numbers. So if you'd like, pause the video now and try working on problem 1, 2, 3, 4, and 5. And if you get stuck or want to check your work, you can resume the video. I'll note that there are multiple ways to solve all of these problems. So if your solution looks different than mine, that doesn't mean it's wrong. Make sure that you run it and you test it and make sure that it's functionally correct. So let's start with problem number 1. Print the numbers all on one line, each number separated by a space. Well, it looks like when I just print out the list on line 106, I can see all of the numbers on one line, but we've got these hard brackets on the beginning and end that comes from our standard list string representation, and all of our elements are separated by a comma and a space. So let's write a simple for loop that will print out each one of these numbers separated by a space, so no commas, and there won't be any hard brackets either. So all I'm going to do is for num in numbers, I'm simply going to print out num, but I'm going to override the default new line character that's put at the end of the string when we call print with simply a space so that they're all separated by a space, not a new line. And then I'll call print outside of the for loop. That way our output for the next time we call print will be on the next line, not at the very end where we have a 9 and a space right here. So here they all are. And you'll note here at the bottom of my 1D list practice problem comments here, I have a note. For practice with functions, try solving this problem using functions. Well, printing out the numbers all on one line, each number separated by a space, is a pretty common task that I might want to do multiple times as I'm solving these 1D list practice problems. So I am going to put this into a function so that instead of having to copy and paste this code, lines 110 through 112, every time I want to print out the numbers all on one line, each number separated by a space, I can instead just write a one-liner to call this function. So I'll call this function prettyprint, since it pretty prints the numbers with no commas and no hard brackets. And prettyprint will accept a parameter that I'll call numbers. I'm going to indent lines 110 and 112 so that they're now part of the body of prettyprint. And now whenever I want to have prettyprint execute, I'll just call it and I'll pass in whatever variable represents a list that I want to print out. Now remember that numbers here, the parameter in the header of our function, is a different variable from numbers here in the prettyprint call as an argument. So I could call this something like, let's say nums. Just want to make it really clear that these are two separate variables. Nums only has scope inside of prettyprint, and then numbers has scope outside of prettyprint, anywhere below where it was declared, which is on line 102. Awesome. Let's move on to subproblem number 2. Sort the list using a list method. Well, there are 2 ways that I could solve this problem. Let's start with using the list method as the instructions suggest. So what I'll do is I'll call numbers.sort. What this will do is an in-place sort of the list, which means that it truly is going to modify the list. So I'll print out numbers, or better yet, I can call prettyprint, that nice reusable utility function that we just wrote, and pass in numbers. So you can see now all of my numbers are sorted from smallest 1 to largest 10. Now, like I said, this list method sort, it operates on whatever list is used to invoke it. That's because it does an in-place sort. Now, let's say I don't want to modify numbers. I could solve this again using the built-in function called sorted. So what's nice about sorted is it doesn't modify the list that's passed in. Instead, it makes a copy of the list, sorts the list, and returns that copy. So let's see this in action. I'm going to have a new variable called sorted numbers, which will store the return reference to a sorted list. So I call sorted, the built-in function. It says return a new list containing all items from the iterable in ascending order. Awesome. I'll pass in numbers, and I'll call prettyprint again, passing in sorted numbers. And we get the same output, but here's the key difference. I'm going to print out numbers. And you'll see that numbers is unaffected by this call to sorted. So here's numbers. In fact, I think I'll put a nice little label over here for our sorted numbers. So you can clearly see that sorted, the built-in function, does not modify the list that's passed in. It produces a copy that's sorted in ascending order. So here's sorted numbers, sorted in ascending order, and numbers is unaffected. Moving on, number 3, print the largest and smallest number in the list. And I've got a hint here. Can you take advantage of the current ordering of your list? So I'm thinking about sorted numbers, or I'm thinking about numbers if I uncomment our original solution to problem number 2, where numbers.sort does an in-place sort, so numbers is in sorted order. Well, looking at my output for our sorted list, the smallest number is always going to be the first element, and the largest number is always going to be the last number, or the last number of the list, because the list is in sorted order, smallest to largest. So yes, we can. So I'm going to print out the minimum, the smallest number. So this would be sorted numbers sub 0. And then I'll print out the maximum, which will be sorted numbers sub -1. And I should see 1 and 10 show up. And I do. Awesome. Let's solve this another way. So let's solve this again using the built-in functions min and max. So let's do print min. I can actually just call min the built-in function. And it says with a single iterable argument, return its smallest item. Awesome. So I can pass in either sorted numbers or numbers. They contain the same elements. And this will give us the smallest number in the list. I'll do the same thing for max. Should get the same output. So there's 2 different ways to solve this problem. Now let's move on to problem number 4, which is going to up the complexity a little bit. Determine the number of times a user-specified number is in the list. So the first thing we need to do is prompt the user for a number. I'll store this number in a variable called usernum. Recall that we can call the built-in function input to prompt the user for a string, and then this input function will return that string, whatever the user types, and then they press enter. So I'll say, please enter a number in 1 to 10 inclusive. And recall that input is going to return a string. So I'm going to put the return value from input as the argument to a call to int in order to convert that string to an integer, because all of the values in my numbers list are integers. So I want to be able to compare this integer to each integer in the numbers list. As we do that, we'll keep track of the number of times we've seen this usernum. I'll do that with a count variable. So now for num in numbers, we'll iterate through each value in the list. If that value is the same as usernum, then I'll add 1 to count. Outside of this for loop, I'll display my results. I'll say there are count of usernum in the list. So let's try it out. It looks like we have 3 7s, so let's enter in 7 as the user and make sure the program says that there are 3 of 7 in the list. Looks like it works. Let's try it another time. Let's see, it looks like there's only 1 4, so let's try 4. It says there are 1 of 4 in the list. Looks like it's working. Let me show you another way to solve this. It's a little bit shorter. I like showing this solution because it's great practice with for loops. It's also great practice with what are called accumulator variables like count that accumulate values over, say, an iteration of something like a list. Or we'll solve it again using a list method. So let me copy this print statement here. And instead of using count, the variable, I'm actually going to do numbers.count, which is a list method. It says return number of occurrences of value. Perfect. That's what we need. So let me pass in usernum, and we'll let this count method do all the heavy lifting for us. This time, let's do 8. Looks like there are 2 8s. So I didn't actually need to write that for loop. There was a list method called count that I could have used instead. But there's not always going to be a list method or a built-in function that will do what you need to do. So it's always good practice to write the logic ourselves. Now we're going to move on to the last practice problem, number 5. This is the most challenging of all. Number 5, remove all instances of a user-specified number in the list. If the number is not in the list, then print the message that says, sorry, your number is not here. Sounds doable? So I can actually just use some of the logic from problem number 4, like, for example, prompting the user for a number. I am going to customize my prompt here a little bit so that they know that this number they enter is going to be removed from the list. So I'll just say to remove. It'll also help me as I test the program because the prompt will be more customized for problem number 5, so I'll know what I'm entering for what. So first, let's make sure that this user num is in the list at all. So I'm going to do if user num is in numbers. If it is, then every time user num is in the list, I want to remove it. I don't know in advance how many times user num is in the list, unless I make use of my count variable, which I could do. I'm not going to do that, however, because there's a simpler way. I don't have to count how many occurrences there are of user num in numbers. I can just say, while user num is in numbers, remove it. The alternative would be to, say, run a for loop that runs count number of times, but like I said, I don't have to count in advance because this handy in keyword in Python will test membership, and this Boolean condition, user num in numbers, will evaluate to true so long as there's at least one user num in numbers. We saw the remove list method in a previous video, so this does an item-based removal. It'll walk through the list and remove the first occurrence of user num. Now I'm going to have an else statement, and in the else statement, I'm going to say exactly what the prompt said to say. So recall the only way to get to this else statement is user num is not in numbers, right? That would be when user num in numbers is false. Outside of the loop, I will simply call our pretty print and I'll pass in numbers just so that we can ensure in the case where user num is in the list, all occurrences of user num are gone. And in the case where user num is not in the list, then the list is unmodified. Let's run this. So please enter a number in 1 to 10. So this is for counting. So let's do 7 again. And now it says, please enter a number in 1 to 10 to remove. Let's do 7 again. And so now I'm printing out the list and I see 1, 5, 9, 8, 5, 8, 6, 10, 4, 9, 3, 5, 3, 2, 10, 5, 9. There are no 7s in this list. I can even use that handy list method, count, and print out the count of user num, and it should be 0. This would be a solution that would work really well if, say, numbers has thousands of entries in it because it's not as easy to manually inspect the list looking for missing values like we just did if there's thousands of numbers in the list. So there it prints out 0. There are no 7s in this list. Now recall the note here, for practice with functions, try solving this problem using functions. So we use a function for problem number 1, but we didn't for 2, 3, 4, or 5. So there's opportunity for you to gain some extra practice by taking our solutions and putting them into nice, parameterized, and reusable functions. So in this video, we covered a little bit more related to one-dimensional lists and how they can be converted to strings and then taken back to lists. And then we did some 1D list practice problems to exercise all these fun built-in functions that work with lists and list methods. Now, I'm going to close this video out by saying stay tuned for the next video, which will resolve these 1D list practice problems using 2D lists so you can get some practice with nested lists. Stay tuned for that. Thanks for watching and consider subscribing to my channel to learn more about Python and data science.